Hello everyone. Once again welcome to PM Networking. Hope you all are doing great. Guys, today in this video we are going to understand MST inter-region concepts. See guys, in last video we discussed MST intra-region, right? We also discussed theory parts of MST inter-region, but we didn't perform practical, right? Lab. So today we are going to discuss more about MST inter-region. So this is my topology for today. As you can see in this scenario, we have two region of MST. You can say this is MST region 1, this is MST region 2. Why I'm saying these are two different region? Because of MST attributes. As you can see here, name is ccnp, and in this domain name is what? ccie. On switch 3 and switch 4 I am going to configure name cci, and on switch number 1 and 2 I am going to configure name what? ccnp. So if any attribute will not match, will not be same, right, then switches belongs to different domain, or you can say different region, right, in MST. So because of this, on switch number 1 and switch number 2 we have different name. Otherwise rest informations are same, like revision number, mapped VLAN, right? Here in this domain also you can say revision number is 1, mapped VLAN, those are exactly same in both domain, but one attribute is different, name is different, right? So two switches, switch 1 and switch 2 belongs to MST region 1, right, and switch 3, switch 4 belongs to MST region 2. Here we have what name? cci. And as you know, as we discussed in last class also, that in each region MST is going to select one switch as a root bridge, right? So in this domain also we will have one root bridge, and that root bridge is called what? You can say what? IST, internal spanning tree. But technically what we call to that root bridge? Regional root bridge. We call to that root bridge is regional root bridge, right? So in both domain we will have one regional root bridge, right? So you can see by default priority on all switches is same. So switch 1 have what? Lowest MAC address in this domain. So switch 1 is going to become what? Regional root bridge, right? Regional root bridge. In the same way in this domain switch 3 have lower MAC address, so switch 3 will become what? Regional root bridge. And in the entire MST domain, right, in the connected region, one switch is going to become what? Inter regional root bridge. Inter regional root bridge. So switch who will have lowest priority, or you can say directly lowest bridge ID, that switch is going to become what? Inter regional root bridge ID, or you can say CIST. Common internal spanning tree root bridge. Common internal spanning tree root bridge. So in the entire domain, which switch have lowest MAC address? Because priority is same on all switches. So switch number 1. Switch number 1 have what? Lowest MAC address. So switch 1 is going to become what? CIST as well. So in this scenario, switch 1 will be become what? Regional root bridge ID. Regional root bridge, as well as this switch is going to become what? Inter-regional root bridge ID, that is CIST. And switch 3 is going to become what? Regional root bridge for this domain. Regional root bridge, guys. But you know, in this domain, in domain 2, in region 2, switch 3 will be always regional root bridge. Even you will configure lower priority on switch number 4, right? Because concept is, you know what? The switch who will have lowest cost to reach CIST, means inter-regional root bridge. Like switch 3 will calculate one cost to reach CIST, right? Inter-regional root bridge. Switch 4 will also calculate a cost to reach CIST. So switch 3 will have lower cost to reach switch 1, means CIST, common root bridge. So switch 3 will be always, you know, a regional root bridge ID. Even you will configure lower priority on switch number 4. I will show you this through practically also, right? Don't worry. But guys, before starting the configuration, let me discuss one more thing here. See, between region, again what I am saying, you cannot achieve load balancing. See, the benefit of MST is we can create number of instances according to our requirement, and we can achieve load balancing. But again, between the reason you cannot achieve load balancing. Here we cannot utilize both link, right? Here we cannot utilize both link because let me discuss MST BPDU again. Guys, MST BPDU is similar like BPDU of RSTP. But there is one extra information, one extra field in the BPDU of MST. That is what? MST extension, as we discussed in last class, or you can say M record, right? This is extra field in the BPDU of MST as compared to RSTP. Otherwise rest information is same, right? Let's say if we have only instance 0 on switches, right, then there is no any difference between BPDU of MST and RSTP if we have only instance 0 exist on switches. So as you know, inside the region for, you can say, intra region, switches is going to check what information for root bridge election. Switch is going to check M record information, right? Or you can say MST M record, or you can say MST extension, right? For inter region, switches is going to check what? MST 0 information, right? MST 0 information. We discussed this in last class also. Here also let me show you where we had discussed this. Here you can see this is content of BPDU, right? So in the BPDU there will be these information. This is information of MST 0 and these are information of M record in the M record field. MST extension, or you can say MST record, or in short you can say M record. So switches is going to check MST 0 information for inter region, for root bridge election in inter region, and for intra region. For intra region, switches is going to check what? M record information. Fine. So inside the M record information, there will be, right, information of, you know, extension MST instance 1, MST instance 2, because in the topology you can see we have two extra instance 1, instance 2, right? So instances information like information of instance 1 and information of instance 2 will be there in the BPDU in which field? In M record field, in MST extension, right? So guys, for it should be very clear to you that switches is going to elect root bridge in the intra domain with the help of M record information, in the inter domain with the help of this information, MST 0 information, right? And in MST record, in M record we have information of, you know, instances, right? Means instances, how many instances we have, like instance 1, instance 2. So see what will happen in this scenario. When switch 1 will become root bridge, first of all this switch will become which root bridge? Regional root bridge. It will send their BPDU from this interface, right? Switch 2 is going to check what? Digest value. Digest value in which field? In M record field. In M record field it will check digest value. If digest value will match, that means both switch belongs to same region, right? Intra region, right? Then it is going to, you know, elect port like root port, designated port, and this switch will not become root bridge. Switch number 2 is not going to become root bridge, so maybe this port will become RP, this port will become, you know, alternate. This is for instance 0 also, for instance 1 also, for instance 2 also, right? After that switch 2 is going to relay that BPDU to switch number 3, right? And when switch 3 will receive the BPDU from switch number 2, switch 3 first will check which information? M record information. Inside the M record it will check digest value. Digest value will not match over here on switch number 3, right? Because digest value is what? Combination of name, revision number, and mapped VLAN. So here name is different, so switch 3 will have different digest value, and switch 1, switch 2 will have different digest value. Then switch 3 is going to check what? Information. Now this is BPDU of inter region, so switch 3 is going to check MST 0 information, right? It will ignore, switch 3 will ignore, you know, M record field like MST 1 information, instance 1 information, instance 2 information. So 3 will ignore those information, right? For inter region, switches will check what? MST 0 information only, as we discussed in last class also, right? So on switch number 3, one port, this port will become what, RP for MST 0, and this port will become what, alternate, right? This port will become alternate 0/1. And now switch 3 will forward traffic of all VLAN from this port only, from 0/1 port, right? From 0/1 port, right? You cannot utilize both link over here between switch 2 and switch 3, right? As I told you, we cannot achieve load balancing between region, right? Between region. So between switch 2 and switch 3, we cannot achieve load balancing, right? So switch 3 will never check information of instance 1 or instance 2 or anything, right? Let's say here you want to achieve load balancing on switch number 2. So what you will think? You will think that, okay, let me do one thing. Let me increase some, priority over here, or let me decrease some priority on 0/1 interface for instance 1. So if you will decrease some priority on 0/1 interface for instance 0, so that this port should become root port. But as you know, switch 3 is not going to check information of instance 1 or instance 2. It will check information of MST 0 only, right, in the BPDO. So guys, this is concept of MST inter region, right? MST inter region. Now I am going to show you these all things practically. Let me access the switches. First let me access switch number 1 here on this switch. So spanning tree summary, which protocol I am running. Okay, so by default protocol is, you can say, PBST. So let me change it. Let me configure MST here. Spanning tree mode, first command is MST, right? Now then I am going to create 2 instances over here, and I'm going to configure name and revision number as well. So say spanning tree MST configuration, right? Here I am going to say what name is ccnp. Then we are going to say revision number. So revision number is 1. Here I'm going to set revision number 1. Then instance 1 and mapped VLAN. In instance 1 we are going to map VLAN 1 to 5. Done. Then instance 2, in instance 2 we are going to map VLAN 6 to 10. Fine. This is configuration of switch 1. Now so spanning tree summary, you can see we are running which spanning tree protocol now, MST. Fine. And so spanning tree, we can say MST instance 0. So for instance 0, this switch is, you can say, root bridge, right? This is common internal spanning tree root bridge, right? As I told you, switch for instance 0 will become what, CIST, right? In previous class, if you have not watched my previous video, first guys watch that video, then only you can understand this one. Now what I am going to do for instance 1, you can say this switch is root bridge for MST instance 1. For instance 2 also, this switch is my root bridge. For instance 2, oh, we don't have instance 2 here. So spanning tree MST configuration, yes, we have instance 2. So spanning tree MST, no MST information available for instance 2. So VLAN brief, actually we don't have VLAN here. So let me do one thing. Let me create some VLAN 1 to VLAN 10, and let me configure the link between switches as trunk as well. So interface range is 0/0 and is 0/1. Say switch port, directly I'm going to say what, switch port mode dynamic desirable, right? So interface trunk, so interface trunk. So fine, these 2 link are trunk link. Now so spanning tree MST 2. So you can see for MST instance 2 also, this switch is root bridge. Fine. Now let me take you to switch number 2. Now on this switch also I'm going to configure first VLAN 1 to 10, exit interface range E0/2 as well as E0/3, or here I can say what, switch port mode dynamic desirable, right? And so interface trunk. So now you can see 0/0, 0/1, these 2 interfaces are trunk, right? Now you can see all interfaces are trunk. Now I am going to configure MST here. So to configure MST, command is spanning tree. And guys, it will be better if we will change host name also. So let me do one thing. On switch number 1, I am going to say host name switch 1. Fine. And on switch number 2, I am going to say first host name switch 2. Sorry, host name switch 2. Then spanning tree mode MST, and then spanning tree MST configuration. Here I am going to say name what, ccnp, same name. Then we are going to say revision number 1, and then instance 1, we are going to map VLAN 1 to 5 over here, and in instance 2, we are going to map VLAN 6 to 10 over here, right? VLAN 6 to 10. Fine. Now, so spanning tree MST 0. So you can see for instance 0, regional root bridge switch is switch number 1. Switch number 1. This is MAC address of switch 1. You can see, right? Regional root bridge is switch number 1, right? And now I am going to configure, for REST VLAN, like for REST instances, MST instance 1 also you can see root bridge switches switch number 1. For MST instance 2 also switch 1 is my root bridge. Fine. This is bridge information, right? And this is root bridge information. Fine. Now I am going to configure switch number 3. So let me access switch 3. On switch number 3, config T, VLAN 1 to 10, exit. First let me configure the trunk interface range E0/2 and E0/3. Say what, switch port mode dynamic desirable. Fine. Then spanning tree mode MST, spanning tree mode MST, and then spanning tree MST configuration. Here I am going to set name what, ccie, and then revision number. Here also I am going to set revision number same. Then I am going to create instance 1 mapped VLAN 1 to again 5, and instance 2 mapped VLAN 6 to 10 here. Fine. Now on this switch, if you will run this command, so spanning tree MST, let's say instance 0, right? Now you can see here we have two information. One is regional root bridge and another one is what, root bridge. So who is this? This is information of, guys, inter regional root bridge, right? Means switch 1 is what, CIST, inter regional root bridge, or you can say common internal spanning tree root bridge. So this is MAC address of switch 1, and regional root bridge is this switch, right? Switch 3 is the regional root bridge in this domain. In the same way, like on switch number 2, again if you will run command, so spanning tree, let's say MST instance 0. For instance 0 you can see regional root bridge. This is information of regional root bridge. Again, this is root bridge ID of switch 1, right? And this is CIST. Again, this is information of switch 1, right? Bridge ID of switch 1, right? So for switch number 2, who is CIST? Switch number 1. And who is IST? Switch number 1. Or in other word, yeah, what you can say, who is inter regional root bridge switch 1, and who is regional root bridge switch 1, right? On switch number 3, who is inter-regional root bridge switch 1, who is regional root bridge switch number 3, local switch, right? Regional root this switch. Now I am going to configure switch 4. So let me take you to switch 4. Here let me verify trunk. So interface trunk. So okay, trunk is already there. And before that, on switch number 3 also I am going to change host name. Let's say switch 3. Fine. Now here host name switch 4, and then I'm going to first create VLAN 1 to 10 over here, and then spanning tree mode MST, then spanning tree MST configuration. Here I am going to set name what, ccie, revision number 1, revision number 1, and then instance 1 mapped VLAN 1 to 1 to 5, then instance 2 mapped VLAN, instance 2 mapped VLAN 6 to 10. Fine. On switch number 4 also you can see so spanning tree MST for instance 0. For instance 0, who is root bridge? This is inter root bridge CIST, again switch 1. And who is regional root bridge? Switch number 3. This is MAC address of switch 3, you can see here, right? This is MAC address of switch 3. So switch 3 is my regional root bridge. For switch number 4, regional root bridge is switch number 3. And who is CIST, inter root bridge, switch number 1, right? In the same way for instance 1, you can see for instance 1 here we don't have regional CIST. Here we don't have CIST. We have only what? Root bridge. This is regional root bridge information. This is regional root bridge information. For instance 1, for instance 2, on switch number 4, you cannot see inter root bridge or CIST, right? Because as I told you, switch number 3 will check what information? Switch 3 will check MST 0 information only. It will ignore M record information, right? And inside the M record information, there is information of instance 1 and instance 2, right? So that's why I told you we cannot achieve load balancing between switch 2 and switch 3 now, right? So for instance 2, instance 1, on switch number 4, we have only regional root bridge. We don't have CIST. CIST, common internal spanning tree root bridge, or you can say inter root bridge, right? We have inter root bridge, inter regional root bridge for instance 0 only, right? Then how switch 4 will forward, let's say, traffic of VLAN 6. So guys, same thing, traffic flow will be like this, same. Let's say switch 4 is forwarding traffic of VLAN 6, right? So for VLAN 6, you can see for VLAN 6, maybe this port is my what? This port is RP over here, so it will forward traffic of VLAN 6 from here on this port. Switch 3 will receive it over here, and switch 3 will forward it from which port? From the RP port. From the RP port. So this port is RP, right? This port is RP, and this port is RP for all VLANs, right? For all VLANs, this port is RP. So here you can achieve load balancing, here you can achieve load balancing, but you cannot achieve load balancing over here. You can see one more thing on switch number 3. Let me take you to switch 3, and on switch number 3 I'm going to show you one thing. So a spanning tree MST 0, right? Guys, you can see 0/0 port is RP. 0/0 port is RP, and as I told you, switch number 3 will ignore M record information, like it will not check instance 1 information, instance 2 information. Then BPDO of MST is similar like what? RSTP. So you can see, that's why you are able to see this keyword here, bond RSTP, means switch 3 have bond the MST BPDO to RSTP BPDO. Switch 3 is treating BPDO of MST, which switch 3 is receiving from switch 2, as BPDO of RSTP, as BPDO of RSTP. Fine. So 0/1 is the alternate port, right? And 0/0 is the RP. What for REST instance? Like let's say for instance 1. For instance 1, you can see 0/0 is what? Master port, right? Now there is no any RP port available here, right? There is no RP port for instance 1 on switch number 3, right? So whatever traffic switch 3 will receive, right, for VLAN 1 to 5 or VLAN 6 to type, it will forward from this master port, from this master port. Fine guys, so this is concept of MST inter region. Now see what you can do if you want to achieve load balancing, let's say between switch 1 and switch 2. So now on switch number 2, so a spanning tree MST instance 0, right? These all ports are DP. For instance 1 also, these all ports are DP, because this switch is root bridge. For instance 2 also, these all ports are what? DP. On switch number 2, let me take you to switch number 2. On switch number 2, you can see, so a spanning tree MST instance 0, right? 0/0 is RP. 0/0 is RP and 0/1 is what? Alternate. And these two ports are again DP because it is forwarding superior BPDU from 0/2 and 0/3, which is connected with switch number 3, right? So for instance 0, this port is RP 0/0. For instance 1 also 0/0 is RP. For instance 2 also 0/0 is RP. So here we are not achieving load balancing right now, right? But I can achieve load balancing. What I can do, I can decrease some priority on 0/1 interface of switch number 2. Let's say for instance 1, right? What I want for instance 1, this port should be what? RP, right? So we can achieve it. Or let's say for instance 2, this port should be RP. Means for instance 0 and instance 1, this port should be RP. For instance 2, this port should be RP. So I can achieve load balancing over here by decreasing the priority. So on switch number 2, I can say what? Interface E0/1 spanning tree MST instance 2, and then we can say cost, not priority, cost. You can change priority to for becoming switch to root bridge for let's say instance 2, right? So in that scenario you can decrease priority as well, right? Now here I am going to let's say cost this one, right? Now you can see, so spanning tree MST instance 0. For instance 0, 0/0 is RP. For instance 1, 0/0 is RP. But for instance 2, 0/1 is the RP, because here you can see we have lower cost, right? So now we have two loop free topology between switch 1 and switch 2, right? But let me take you again to switch number 3, and here let me try to perform load balancing, right? On switch number 3, what is happening now? Actually, on switch number 3, you will configure lower priority over here. It will not check information of instance 1 and instance 2. It will switch 3 will check only MST 0 information, right? So here if I will even configure lower priority on 0/1, interface is 0/1, say spanning tree MST for instance 2, and say cost what? Let's say only 1000, okay? And so spanning tree MST instance 2. You can see for instance 2, still this port is what? Master port. Because for instance 2, here we don't have RP port, right? So switch 3 is not going to select RP port over here, right? We don't have RP port for any instance except instance 0, right? So for if you will change priority on upper port on 0/1 port for instance 0, then definitely this port will become what? RP, right? So here we cannot achieve load balancing. And now the last thing what I want to show you, that if I will set priority 0 on switch number 4, then definitely switch 4 will become what? Switch 4 will become inter-regional root bridge, because on switch number 1 we have priority what? 32768. So first I am going to set priority 0 on switch number 1. On switch number 1 I am going to set priority 0 here. Spanning tree MST 0, MST 1, MST 2. For all instances I am going to set priority what? 0 here. Now so spanning tree MST instance 0, right? On switch number 2 let me verify it, or on switch number 3 also we can verify. So spanning tree MST instance 0. Now you can see priority of bridge is what? 0, right? Now on switch number 3 we have what priority? Guys? Here on switch number 3, 32768. We have 32768 priority over here on switch number 3. So spanning tree MST, let's say instance 1. You can see priority over here is what? 32768 and plus instance number 1. That is 9. Now I am going to set lower priority on switch number 4. So switch 4 should become what? Regional root bridge. Switch 4 should become regional root bridge, right? For let's say instance 1. But still switch 3 will be your regional root bridge, because switch 3 have what? Lower cost to reach inter-regional root bridge, CIST. So in the different region switch who will have lowest cost to reach CIST, that switch will become what? That switch will become regional root bridge. Note the switch who have lower bridge ID. So if I will configure lower parity over here, let's say on switch number 4 I'm going to say is a spanning tree, and then MST, let's say instance 0, instance 1, instance 2, and I'm going to say, let's say priority what? 4096, right? So here I have configured priority what? 4096, and on switch number 3 by default configure priority is 32768. So now switch 4 have what? Lower priority. So a spanning tree MST, let's say instance 0. For instance 0 you can see bridge ID. Priority over here is what? This one. And regional root bridge priority is what? 32768, right? Still, who is regional root bridge? Switch number 3. This is MAC address of switch number 3. Why? Because switch 3 have lower MAC address to, sorry, lower lower cost to reach root bridge. Which root bridge? Inter-regional root bridge, means CIST. Fine, guys. So this is concept of MST inter-region, right? So again, question is, disadvantage of MST is what? We cannot achieve load balancing between two region of MST, right? Now hope this is clear to you, like how MST inter-region works. If guys you have any question, please let me know in the comment section, right? Definitely I will make one another video to resolve your query. For me, that's all for today, guys. If you have learned something from this video, please hit on like button. If you have not subscribed the channel, please subscribe the channel. We will meet soon in next video. Till then, stay safe. Bye bye. That's all for today. Thanks for watching.